Hi, this is Paolo Zama from CAREL Industries, and with this tutorial I will show you the complete life cycle of a project, starting from the creation till the upload of the software into the Pico. This is the exercise I'm going to create. This is a simple thermostat function, direct, so I will read the room temperature from the analog input number 1, that is the first available in the Pico. I suppose to use an NTC sensor, and then we will compare the value of temperature with a fixed set point and a differential of 20 and 1 degrees. In order to create a stage, direct stage like this, representing the status of the cooling, and with the status of the cooling we will drive the digital output number 1, that is the first relay that is available. Regarding the user interface, we will use a terminal with a PGD1 display which has 8 rows and 22 columns, and we will show a description of the values that we will show, and beside the value of temperature and the status of the cooling. So let's start. Let's create a new solution. A solution is a collection of project application. We will create a solution with only one project application, that is the one for the exercise. Let's give a name. We can change the folder where to save the solution folder, but it's good in this place. Other properties are optional, so we can go to the next step where we can define the application project. New is for creating a project from scratch, completely empty, and while others is for copying from existing solution, project from existing solution. Okay, let's give a name also to the project, application project. These are the languages we can use for the strategy. The first is the function block diagram, also called FBD. It is a graphical language, while the second is the structured text, ST. As the name states, is a textual language that looks like Pascal. All the exercises that we will do use the FBD language. Well, these properties are optional, so continue. Here we have to select the type of controller. Beside me, here I have a simulation box for a Pico 1 with 2 MB of flash memory. And this is the label for that controller. PGD1 is the default display for new project. It is the one that we wanted to use, so we can continue. And this is the languages of the text. There is a specific exercise regarding the languages, the translations, and so on. So for now I want simply to remove Italian language and add the English. Okay, that's all here. So finish the wizard, and then the Solution Explorer shows a view on the complete solution. This is the list of the projects, so only the course project, containing the pages for the strategy, the control strategy, pages for the mask, that is the user interface, resources is for graphical resources, the images we wanted to show on the display, documents is a generic container of documents, dependencies and lib is for the function block libraries, network is for the local network, for the links in local network, and the project touch editor is for the PGD touch. Okay, we can start from the strategy. So let's open the strategy page. Here are the libraries of blocks. All blocks looks like this, that is a square or rectangle with the input and output. The block receives the value to process on the input pin on the left, implement the function and returns the value into the output pin. For our exercise, we need of a block for reading the analog input, and this is the block. All blocks have an online help, online guide, so just click the block and press F1 or right click question mark. So the guide starts with the description of the block, how it works. At the end, there are the links to specific pages for the inputs, description of the inputs and description of the output. This block, for example, has two inputs, CH, that is the channel that indicates the value of the number of the input to read. That is the number that appear in the terminal block, in the label in the terminal block. While type is a number indicating the type of electrical signal of the sensor, NTC or PT1000 or 0 to 1 volt for 20 milliamps and so on. So let's define the channel. We say that I say that it is a channel number 1. So I will place a constant number 1. I click near the block, ask or right button to stop this sequence, and now click one of the two pins, move and release to place a connection. Now the two objects are connected and remains connected. And after that, type is a type of the sensor. I say that is type 0, that is NTC. So another constant. Okay, 0 is okay. Click ask, click move, release. Well, so this block returns. We can see here, this is type 0 NTC, returns the temperature expressed in tenths of degrees centigrade. So since we want to show that value into another editor, it is mandatory to save that value into a variable. So we can create a new variable. I will call it room temp. Description is optional, but I prefer to write room temperature. Data type, I will use analog. Analog is like an integer, but the editor shows the decimal dot before the last figure. Field access, only output. Only output means that the value will be only shown in the display, so the user can't change it. It's a sort of read-only. For the user means read-only. Format is defines the number of characters we want to reserve in the display for this number. I will use this. So this is suitable for values from minus 99.9 till plus 99.9. And for our room temperature is enough. Okay, click somewhere, ask to stop, click move and release. Well, next step, we have to compare the temperature with the set point and the differential fixed. For this, there are several blocks. The block that I prefer to use is this block with a strange name, GRDCMP, comparator with gradient, something like that. It works exactly as described by the icon. So the in is the value we want to compare. In this exercise is the room temperature. So we can connect it here or directly to the output of the previous block. set differential are constant and fixed values, so I will create a new constant and 1, 0. So the values are expressed in tenths of degrees like the temperature. To connect the constant to the pin, I will just move it close to the pin and you can see the result. Well, so this block returns a Boolean value 0, 1 according to this operating graph. Like before, in order to show the value in the mask, in the other editor, I have to save it into a variable. So I will create a new variable, description type Boolean is enough because it is in the range 0, 1. Only output, that's okay because we want only to show it in the mask, and so finish. Mask, drag and drop. Next step, we have to drive the digital output number 1, the relay, with the variable cooling. So to drive a physical digital output, there is a specific block, D-out, digital output, like the first block, CH indicates the number of the output, in this case we want to drive. That is the relay number 1, so I will place not a variable but a constant number 1. Val, I would say, obviously defines the status of the relay. In this exercise is the status of the cooling, is the value of the cooling variable or the output of the other block. It is the same. Well, that's all regarding the strategy. So let's have a recap. So this block will read the analog input, the sensor number 1, type 0, that is NTC, saves the value into the variable room temperature, that is compared with a fixed set point differential 20 and 1 degree. According to this stage, this block defines the cooling status saved into the variable cooling, and it is used to drive the physical digital output number 1, the first relay. Well, now we can continue with the user interface. So open the page of the mask editor. There are a lot of windows. Don't scare about it. This white rect represents a mask. That is a page, display page, screen page. It is empty because it is a new project. So let's place a fixed text. Room temperature. I have to shorten because no space for the complete word. And another text with cooling status. And beside we have to show the variables. We have to use another object, that is the field object. Here we have to select the variable we want to use in that field, so room temperature. In the bottom part there is the format. The default format is the one that we have defined when we have created the variable. It is okay, so continue. Place another field with cooling. Just to complete the mask, we can place a text with the unit of measurement of the temperature. For this, I will use a special character in the char map, that is this, where in the same character there is the circle, small circle, and the C for centigrade. Next step, compile. Compile means translate the high-level language blocks or text fields and so on into a format that can be used by the controller. To do this, we have to use this button, but before to do that, I will show also the other buttons. Anyway, all these are available in the compile menu. Well, save is save solution, it's clear, it saves not only this mask or not only this page, but all the solution and its projects. Besides, there is a verify. Verify checks for some errors, not all, but some errors. Doesn't create the files for the controller. Okay, we use it. And next, there is the button that we want that we need. Compile means I show you, it means save, verify, and compile, all in the same time. Compiles checks for all possible errors. It also creates the binary file for the controller. And after that, we have two options. The first is to test the simulator in the PC, and the other option is to test the application in the real physical target. Of course, we will take this way first. Okay, this is the button to start the simulator. So it saves, verify, compile, and if there are no errors, start the simulator. This is the first window of the simulator where we can select the model of Pico. I will use the Pico 1 small because we have only only few input and outputs, so that is enough. This property is also used by the simulator to show the same number of input and outputs of this model of a controller. Okay, I will open also the Solution Explorer and the simulation of the physical analog input and the simulation of the physical digital output. The display is blank. Why? Because I have to start the simulator first, and now we can start to increase the temperature and see if the project works. So I'm using a set point of 20 degrees and a differential of 1 degree. So I expect to have the cooling on at 21. Okay, so we have the feedback in the mask as well as in the simulation of the physical relay. So it works. Okay, if I increase, nothing happens. And now at 20 minus 1, 19 should switch off. And okay. Okay, for the test is enough, but I can take the opportunity to show you other interesting feature of the simulator. Two features. The first is the watch window. There is also a button here. A watch window is a simple list or table with variable and value. So we can add the variable of the project like this, and we can see the instant value of that variable. The second is this. We can have the view on the strategy, also other part of the program in a read-only way, so we can't move or modify. The advantage to have this is, okay, we can use it to check how has been done the strategy, or with the eye we can show the instant values of variables and the input output of the blocks, so we can see how the blocks are working. Okay, we can populate the watch also with a drag and drop of the variable there. Well, next step, we can test the software into the real physical controller. So we have to upload it first in the controller. There is a slide with the steps to upload the software in the controller. First of all, we have to disconnect the Pico from the display and connect it to the PC. Okay, here we have a better view. So we have a converter, a USB in one side connected to the PC, and RS485 in the other side connected to the Pico in the same connector where normally you have the terminal. After that, we have to start the Pico Manager. So stop simulation, start Pico Manager. Pico Manager has a three component, Pico Load, Commissioning Tool, and Log Editor. For now, we need this, the Pico Load, where we can download files. But before to do that, we have to connect the Pico to the PC. So first of all, we have to select the COM port. We are using a serial converter, so it is identified with a label like this: COM1, COM2, COM3. If you don't know what is the exact label, instead of to enter in the device manager of the PC or Windows, you can use the wizard. The wizard asks you to disconnect the converter. Now I reconnect the converter, and here is the right label. After that, we have to set the device address, the address of the Pico. If we know what is the address, it's better to select manual and write here the number, because the Pico will become online faster. Else we can leave automatic. So Pico Load will try to get online with all addresses available in the network, but this could take a little bit longer time. After that, click Connect. Now the controller is still offline, and it takes about 20 seconds to get online. So switch on the simulator. Let's wait 20 seconds. Now I skip this time. Okay, now Pico is online. In the device info, Windows shows the type of the Pico, date and version of boot and BIOS, that is the operating system, the amount of memory installed on the controller, and so on. Okay, here we have to select the files we want to upload. There are a lot of files, but the minimum file that we have to select are these two. The files containing the masks, the user interface, and the files containing the control strategy. These files are created by the compiler. They are already selected, as you can see, so I can go straight to upload. So also this procedure takes some time, so I will skip this delay. Okay, upload successfully completed. Close, stop. Now Pico is restarting, so I disconnect the PC and reconnect the terminal. And this is the result. Temperature is 18. Now I increase the temperature, so at 21. Okay, switch on and go down, 19. Okay, that will switch off, so it works perfectly. Next step is not mandatory, it's optional, but is strongly recommended, is a backup, that is save the solution folder in a safe place. To do this, we can use a built-in function of the one tool, is the file backup solution. Standard format is a simple zip file. I prefer to organize my backups, so I will create a new folder where to save all the backup. The name of the file is, the folder name is good, is a solution folder, and the date, but I recommend you to add other info like this version, the version number 1.0, 1.1, and so on. In this case, this is an exercise, so a good name could be this one. Exercise 1, thermostat. Start. Okay, and we made also the backup. Now we could start with the second exercise. We could start to modify again the strategy and the user interface, as well as we could restart in case of errors at compile time or errors or problem at debug time. Well, this is all for our first exercise. Thank you for watching this tutorial.